All right, today, what we're going to do is go through the Chapter 5 test review. Now, if you, for some reason, think you'll miss the end of this week, you won't be in class for the test Thursday, Friday, or I guess A-Day Thursday and B-Day Friday, then what you can do is you can go ahead and take the test right now. I'll show you where everything's located. Let's get to your digital classroom. And if you go to classwork, we're looking in Chapter 5, and you'll see this test review. That's where I'm going to be working today. Now, if you want to go ahead and start the exam, you can do so by clicking the Chapter 5 exam link and following the instruction there to taking it through School City. I'm going to open up this Chapter 5 test review. When I open it, I'm going to click, or I'm going to walk you through. First is submit your attendance. You need to do that today. If you want a digital copy of the review, you can click the second link. And the third link will take you through the review, the YouTube videos where I made video one at a time all the way through. Like I separate them by problem, as you can see, for the 20 problems. Okay. I'm going to open up these three resources. We're going to use the pre-programmed graph, so I'll open that up. We will use the formula chart and the unit circle today. So I'm going to open up those three. I'm actually going to close this unit circle because I have a different one that I will open up whenever I want to use this problem. I'll just drag it over to my notebook file. So I'm going to close that one for now, but I will leave open the formula chart because we'll use that a whole lot today. I say that there's a certain number of problems that we'll use this, and then another set of problems that we're going to use pre-programmed graphs. Okay, with that, I'm going to go ahead and get started. And I'm going to widen that out just a little bit more. Okay, so again, this is the Chapter 5 test review. You can go to your, that same file I was just showing you, Google Classroom, and click on this digital copy. And it'll open up exactly what I'm working on. For whatever reason today, I don't know why, there's a couple errors. So let me really quickly fix this. All right, there we go. I fixed these problems there. So let's get started. One thing I want to note is on the side, if you look over here, it'll tell you which lesson all these come from. So if you want to get when I go through more detail, you can open up that YouTube playlist for each of those as we go through, and it'll help walk you through how to solve each problem. All right, let's start with number 1 here. It says could rewrite 785 degrees in radians as a multiple of pi. So 785 is in degrees, and we want to convert it to radians. And you might remember that we created a calculator for this. So I'm going to go to the spring semester, and this was the second lesson. It was lesson 4.2, and 4.1 is when I use this calculator. I'm going to open up this second one right there, convert radians and degrees. When I open that up, it reminds us that pi radians is equal to 180 degrees, and this will be number 2. I'll get to there in a second. So pi radians is equal to or equivalent to 180 degrees. So what does that mean for converting? Well, if you want to convert 785 degrees and convert that to pi radians, you need to remember that pi is equal to 180 degrees, which means for conversions, the way you learn this, I think in your science classes that do so well, so they say, okay, if you want to simplify out the degree symbol, if you're multiplying by degrees, you can, if you divide by the degree symbols will cancel each other out. But in math or science, you can't just add a multiplication and division without changing the problem unless the value equals 1. Then it would remain as equal to itself. Well, it's kind of a tricky way of saying I'm ultimately multiplying here by 1. Pi is equivalent to 180. So that's like multiplying by 1. It just is going to look different because the degree symbols will cancel each other out. And then we can reduce. I'll use the calculator here. 785 divided by 180. And I'm going to hit the fraction button on the left side, that little button right there. That's going to give me, in terms of fractions, this value right here would equal 157 pi's. Because notice in Desmos, I did not type in the pi symbol. And that would be divided by 36. Since I did not type in the pi symbol over here, I need to add it on this side. And that would be my solution. 157 pi's divided by 36. And that's how you convert, just like that. Now, number 2 works the same way. It says rewrite 39 degrees, 12 minutes, 59 seconds in decimal degree form. Now, decimal degree is where you have a decimal after the degree, or after the whole number, but before the degree symbol. So I can tell you right now, my answer is going to be 39 point something degrees. So you just have to convert this out. Now, the conversion is shown right here, that 1 degree is equal to 60 minutes. That's what that one little tick mark means, one little apostrophe. And that 1 minute is equal to 60 seconds. And so what I will do here is I'm going to say 1 degree equals 60 minutes, and 1 minute is equal to 60 seconds. And so let's convert this. I have the whole degrees there. I'm going to start with this seconds portion and say 59 seconds. I can convert that to minutes and say, okay, well, if I want to get rid of the seconds, I put the full seconds in the denominator. So this will now simplify out or cancel each other out. In 60 seconds, it has to be equivalent to something up here, and that would be 1 minute. So when I do that math, we could get the decimal. Let's see here, 59 divided by 60 is, let me shorten it just a little bit, is 0.983 repeating, 0.983 repeating. Now that's how many minutes that we have right there, because the seconds cancel each other out. So 59 seconds is 0.983 repeating minutes. So now what I do is I take it and I combine it with this amount of minutes. So I now have 12.983 minutes, and I want to convert those to degrees. And so now I'm going to use this conversion, that in every 60 minutes we have 1 degree. And so now let's take that value. We're going to say 12.98, and you can just do a bunch of 3s if you want. And we'll divide that by 60. Oops, I pressed minus. Try this one more time. There we go. Divided by 60. And this tells me that after I do my conversion right there, or I simplify out the minutes, that I have 0.21638 repeating. Degrees. Okay, now I knew it was 8 repeating, even though it ends with the 9, it's just because they rounded that off. And so this says round to the nearest thousandth. That's the third decimal place because 1,000 has 3 zeros. So it'd be 216 here for my answer, 39.216 degrees. That would be my answer. So that's how you convert. And again, those both came from lesson 4.2. And you can make a note on here to use the Desmos conversion calculator. Whoops, forgot the S, conversion. Okay, so now let's go on to number 3. I wrote here at lesson 5.3, I actually started showing up these problems as early as the ACP problem on lesson 4.1 and in detail in 4.3. So we saw this quite a bit earlier, but it actually shows up in the textbook on lesson 5.1. It says, given sine theta equals -20/29 and cosine theta is greater than 0, find 5 remaining trigonometric functions. Now to help us out on that, I'm going to go to the basic trig calculator. Now the reason I'm going to open this one up, calculator number 11, is because I want to use these 3 ratios right there. I'm going to clear this off so I'm going to use these 3 ratios. And let me see if I can make this any bigger. It doesn't change the size, unfortunately. Okay, so it says sine is -20/29. And I want to remind you that sine over here is listed to y as equal to y/h. So I can substitute. There was a rule we learned, and that the hypotenuse is always positive. So that means the y takes the negative. So it'd be -20 divided by 29. And this says cosine is positive. Well, cosine is x/h. So we'd say x/h is positive. Well, we know h is 29. So I could say h is 29, that this x/29 is positive. Now, if I wanted to solve this, I would just multiply both sides by 29. And so that eliminates that. And so we have that x is greater than 0, which means x is positive. Now, if you have y and h, the only thing you have to do to find your x is Pythagorean theorem, and we know that it's not going to be a negative x, it's going to be a positive x. So now I'll do my Pythagorean theorem that x squared plus y squared will equal our hypotenuse squared, where the x is unknown, just a positive unknown number, y is -20, and h is 29 squared. Because I have a lot of problems to work through today, if I know the number, I'm going to tell you the number. I know, whoops, -20 times -20 is 400. That I know. And 29 squared, I do not know. 29 squared, that's 841. So a little algebra here. I'm adding 400. What's the opposite to get x isolated here?
Subtract.
So we have x squared equals 441. And then we'll take the square root. And so we find out the square root of 441 is 21, which means x is not plus or minus. Normally, when I add a square root, I would say it's got to be, when you add a square root that comes with the plus or minus. But in this particular case, we know x is positive. So x is going to be positive 21. And so to get our 5 different ratios here, you just follow these ratios listed on the left side. So cosine is x divided by h, which is 21 divided by 29. 21 divided by 29. Tangent would be y over x, so -20 over 21. Cosecant is h divided by y, so it'd be 29 divided by -20. 29 divided by -20. I don't have much room to write the fraction with, so it kind of looks funny, but that's a 29 divided by -20. Secant would be h divided by x, so 29 divided by 21. And cotangent would be x divided by y, so 21 divided by -20. And that would be my solution to number 3. And so on this one, I used a right triangle trigonometry calculator, right triangle trig calculator. Okay, number 4, it says find the exact value of each trigonometric function. So it's basically like number 3 here, except this time they gave us a triangle to work with, which means if you're looking at an exact triangle, you always deal with positive numbers. If it's a triangle already given to you, you're working with positive numbers. Our y is 10, our h is 12. Oh, I can already tell you, this is gonna be nope, it's never mind, it's not gonna be. So how would I solve for a missing side on a right triangle? That means a triangle with a right angle. What would I do to find the missing side length on a triangle? I have a message, Pythagorean. I would use Pythagorean to solve. So I'm going to have my x squared plus 10 squared is going to equal 12 squared. So we'll have x squared plus 10 times 10. Does anybody know what 10 times 10 is?
100.
100. And what about this one? 12 times 12?
144.
144. All right, good. So let's do a little algebra here. I'm trying to isolate the x. And so how do I get rid of a plus 100?
Subtract it.
Subtract it. Good. Thank you. All right, so now we have x squared equals 44. Okay, again, to isolate the x, it's right now being squared.
Yeah, it's a square root.
There it is. The opposite operation would be to square root this. And normally it comes with a plus or minus, but because this is a real triangle, we're only going to deal with the positive. So real triangles have positive lengths. So it'll be the positive of 44. Now today you're going to see me try to reduce a lot of square roots. And the way I'm going to do that is by upside down division. I'm just going to ask myself, starting with the lowest prime numbers possible, if a number can go into this, and I'll show you how this reducing a square root works. So I'm going to try to divide in 44 with the prime number 2. So 2 does go into 44 22 times. And I ask myself again, can 2 go into that? Yes, it can, 11. And then you would go, can 3 go into that, 4 or 5? No, because 11's prime. I can't go any further. If you have a pair, that pair comes outside of the square root. So the square root of 44 can be simplified as, and it only comes out as a 1, single, 2 square roots of 11. Since 11 was a single, it remains in the square root. And if there were more singles, you just multiply those together and put them down in the root. If there were multiple pairs, you'd multiply those together and move them out front. But since it's just one pair, it's just 2 square roots of 11. That's what x equals in reduced form. So to get our values here, I'm going to use the same trig ratios, y over h. So sine would be 10 over 12, which will reduce to be 5 over 6. Okay, and from here on out, I probably need to simplify these. Since 2 can go on all of them, the values I'm actually going to be using for these ratios from here on out is I'm going to say, I'm going to divide all of them by 2. And it'll make it cleaner over here. So I'm going to reduce or simplified. Let me write it this way, simplified. These are my simplified values here. And so cosine will be x over h, so square root 11 divided by 6. Tangent is y over x, so it'd be 5 over square root 11, 5 over square root 11, which will equal, when you shoot that square root up, 5 square roots 11 divided by 11. Now that one's tricky. Cosecant is h over y, so 6 over 5. Secant is h over x. Again, I'll have to simplify that, so it'd be 6 square roots of 11 divided by 11. I have to rationalize the denominator, so I shot the square root up. And then finally, cotangent would be x over y. So square root of 11 divided by my y value of 5. So that would be my answers there. I will show you this tangent off to the side here. You'd have 5 over, tangent is y over x, so 5 over square root 11. And so basically what happens when you multiply by the square root of 11 over square root of 11, so what I call shooting it up, you'll have 5 square roots of 11 in the numerator, but the denominator 2 square roots multiplying that are equal will just take away the square root. And that's why I got this 5 square roots of 11 divided by 11. And secant work the same way. All right, let's go on to number 5. Number 5 is lesson 4.2. We're dealing with radians and degrees, and it says here a sector, which is a portion of a circle, of a circular patio, intercepts an arc that is 13.2 meters. That's kind of another way of saying arc length. It's like a portion of the circumference, and it has a central angle of 32 degrees. Find the diameter of the patio. Okay, so the first thing you need to remember from lesson 4.2 is that we had a formula. And the formula was this. It was if you remember how we develop what a radian is, 1 radian is when the radius, my screen, thing's pausing on me a little bit now. When the radius has the exact same length as the arc, which they name the letter with that as the letter S. When those two match, we create the angle, what we call 1 radian. That's where a radian came from. And it was in that lesson we came up with this formula that S, meaning arc length or intercepted arc, equals the radius times theta if you're in radians. Now, we're not in radians, we are in degrees in this problem. So any problem we learned in that lesson that was in degrees, you would start with the same formula, but you'd have to convert it. Now, we converted earlier on number 1. Conversion is pi and 180. And so if you were in degrees, you would end up needing to cancel degrees, which means you'd put 180 degrees in the denominator and pi in the numerator. And so this was the formula that we learned on lesson 4.2. You could write this as one fraction, like r theta pi over 180, but I'll just leave them separate. That's the formula we're going to use. On this particular problem, they tell us our arc length is 13.2. They also tell us our theta is 132 degrees. We want to find the diameter, and I want to remind you that diameter equals twice the radius, or 2 radiuses. So to solve this, we'll take our formula, this formula right here, and we're going to say 13.2 equals the radius, it's unknown, times 132 degrees times pi, and divide that by 180. And that could go all the way across. That's what I was saying. You could rewrite this as one fraction. To solve this, let me actually shift it up just in case I need the space. Not sure how many algebra steps this will take. To solve this for r, to isolate the r, we need to do the opposite operation. So right now, r is multiplying with 132 degrees. Let me simplify those out of there. Those cancel. So r is multiplying times 132, and it's also multiplying times pi, but it's being divided by 180. So what I need to do is do the opposite here. I need to multiply by 180 and divide by 132 pi. That will simplify out the 132, the pi, and the 180. But if I do this on the right side of the equation, I need to also do this on the left, on the left. So we're going to multiply by 132 pi over here. Now this doesn't say about how to leave your answer. So I'm going to type it in as is first, and we'll get it as a decimal, and then I'll do it again in terms of pi. So the radius itself would be 180 times 13.2 divided by, that's kind of weird, let me do it divided this way, divided by 132 pi. Now that would be my radius. So I'll put r equals. That's my radius. And if that's what r equals, then d would equal 2 times my r, which is this value right there. Okay, so the first answer I want to put is the decimal form, and it doesn't say what to round it to. Earlier we rounded to 1,000, so I'll round this to 1,000. That means 3 decimal places. So we could say that the diameter would be 11.459 meters. So that was my r. What was r just as decimal? Let me see what that is as a decimal, just for the sake of notes. It was 5.7296, I'll say that, rounded. Okay, and so d equals 2 times the r. And so that's how we got our diameter right there. Now, if we want it in terms of pi, what you would do is you'd come back over here and you would not type in that pi like that. And so now this is going to be in terms of pi. So it's 18, and then when you take 2r, you get 36. So you could say it is, or 36 over pi meters. You could write the answer either way. So it's either 11.459 meters, and this is in meters here, or it's 36 divided by pi meters. Let me check that just to make sure I'm right. 36 divided by pi, yeah, that's the same number. So that would be in terms of pi. Depends on how they want the answer. Okay. Let's jump on now to number 6. It says identify the coterminal angle between 0 and 360 for angle negative 85 degrees. I'm going to draw a little unit circle looking, well, I'll just put a circle on the line, call it a unit circle. Let's put a circle and just remind you that when you find degrees, you start from the positive x-axis. That's where our standard position is. And so this would be the initial sign, which would be located at 0 degrees, which we also know is 360, 0 and 360. The terminal sign is at negative 85. Now, negative just means the angle does not go upward, it goes downward. And so negative 85 would be almost here to the negative y-axis because that would be a negative 90 degrees, a right angle. This is not quite so. So this would be negative 85 degrees right there. Now that's what the angle looks like. Now this says identify coterminal. Okay, now here's what coterminal means. This is the terminal side of the angle. Coterminal means having the same ending point. So it ends the same location. However, the angle needs to be between 0 and 360, which means you need to find the angle as if it went around this way. That's what we're looking for. How many degrees is it to go around that way, around this circle? Let me put this x and y axis on there. Okay, so what do? Well, we learned in lesson 4.2 that to find anything coterminal, to find a coterminal angle, you take your angle, whatever that is, and you add or subtract 1 revolution or a revolution. You can do more than 1 revolution for that matter. So I'll put it in parentheses, revolutions. You could add multiple revolutions if you needed to, but on our problem, I think if we have negative 85 right there, if we add 360, which is a full revolution, let me write that in there. A revolution means all the way around the circle. A revolution could equal 2 pi or 360 degrees. If I just add 360, I should get my answer. So what we're going to do is take negative 85 degrees and add that full revolution of 360 to get our solution here. So it'll be negative 85 plus 360 is 275. What we just learned is this angle right here would be 275. Because that's negative 85 plus the 360. That gets us these negative 85 degrees and all the way around. It's like a full circle. You just add the 360, and that's where we got 275. And that would be our solution. Now, our test has 4 pages to it. If it was in paper copy, this is the front page. Let's check out second page here. It says find the exact value of cotangent secant inverse 11/9. And I do want to remind you now as I get more into what I would call algebra. So this is more conversion, just the basics of each of these shapes, stuff like that. As we start getting into some solving, I want to remind you that the calculator can handle a lot of these. So what I'm going to do is I'll show you kind of the calculator, and then I will show you how to solve it by algebra using your hand, okay, or your paper and pencil is what I mean by that. So let's just check this out. If I type that in, let's see what the calculator says. Cotangent of secant inverse, so power -1, and I need to add one thing for Desmos. You need to add a parenthesis around that after the secant inverse. So I'll say 11 divided by 9, and it gives me this decimal, and there's no option for a fraction, which means this either has a pi or a square root in the answer. If it doesn't give it to you as an option of a fraction, it means that there's either a square root or a pi in there. So we'll figure that out as we go. But this should be our solution. Whatever we get, if there were multiple choice, we should be able to test our answers against that decimal. So if I was doing this by hand or by paper and pencil, what would I do first? Well, this comes from lesson 4.6, which was composition of functions, which means, which is built off of chapter 1. We did something similar in chapter 1. I believe lesson 1.6, we did composition of functions. But now with trigonometry, this means, according to PEMDAS, I need to solve the inside first. What this is saying is that the secant inverse is -11/9. So normally we write secant like this. We'd say secant theta equals h/x. And so a secant inverse, what that does, if you remember, inverse will exchange the domain and the range. And when I say exchange, I mean substitute. We'll substitute the domain and the range like that. And so they're telling us that the h over x is 11 over 9. That's what they're telling us. So let me write that down. That h over x equals 11 over 9. Now this portion is saying cotangent. We know cotangent is x over y. That's what we're supposed to find. The question's asking us basically, what is the x over y given this information? And so we already know x. The answer is going to be 9 divided by something. That's what I already know. I'm going to be looking for x divided by y. X divided by, sorry, y, not 9, y. So we know x is 9. We don't know y yet. And so what we would need to just do is Pythagorean theorem. Now there's one more thing I need to remind you of before we continue on with that. And that is when we did inverses with trigonometry, which was less than 4/6, we had to restrict the domain. When you start with an inverse, you restrict the domain. So the cosine and secant family restrict this portion of the graph. This portion for secant inverse is restricted out. So whenever they start with a inverse, you restrict half the graph. For cosine and secant, you restrict this lower half, which means all answers are going to come between 0 and 1 pi. Or said another way, no matter what, the y's here, this is my y-axis, the y's will be greater than 0. No matter what, or greater than or equal to 0, I should say. Y's will be greater than or equal to 0. So when I do my Pythagorean theorem here, my y value will have to be positive. So I'm going to do this to solve for my y. We know x is 9. Y is unknown other than the fact that it has to be positive because secant inverse would eliminate the negative y's, this lower half of the graph. And h is 11. All right. Anyone out there on Zoom? 9 squared. You know what 9 times 9 is off the top of your head? Very good, Rand. That's 81. Very good, Kira. Y'all are quick. Ooh, what about 11 squared? Gail, way to go. Yeah, 121. So I'm trying to isolate the y here. So 81 is adding. So we got to do the opposite operation. The opposite of adding is subtraction. And so we have y squared equals 121 minus 81. 12 minus 8 is 4. So y squared would equal 40. And now I asked this question earlier, I'll ask it again. What is the opposite operation of a square?
Square root.
Square root. Okay, now normally when there's a square root added, it needs to come with a plus or minus. But this one we've already established that y has to be positive. So I'm not going to take the plus or minus. Now, I told you earlier that this problem must have a square root or a pi to give me not an option for the fraction. But I also told you earlier in this lesson that I was going to work on reducing square roots. So this is one of those. I'm going to take the lowest prime number other than 1 and go into 40s, which is 2. 2 goes into 40 20 times, and 2 can still go into 20 10 times, and 2 can go into 10 5 times. So I look for pairs. It appears to me that I have a pair of 2's there. I have a single 2 and a single 5. What that means is y will equal, the pair comes out, and the singles go underneath and multiply. So y is 2 square root of 10, which I won't leave my answer in that form. I will rationalize the denominator, which means I need to shoot up the square root. So 9 square roots of 10 over 2 times 10 is 20. That would be my solution right there. All right, let's check it. We were supposed to get this decimal. Let's see. If you were on your test, by the way, you would have multiple choice and you would have had these different options. You could have typed them in and saw which one of the multiple choice matches decimals? You'll see we did that correctly. We got the right value. All right, let's try the next one. So this one, if we were going to try to solve it with the calculator, you would need to remember that inverse will swap these two around. Now, I don't know what the trick for this part, this portion, other than you have to use x on Desmos instead of theta for some of this. So what I'm going to do here is I'm going to say sine inverse. I'm going to try. I might end up finding out that I can't solve this problem in the calculator. We'll see here. Negative square root of 3 divided by 2. So it's giving me a value. I'm obviously in degrees. I'm going to change to radians. This is what we typically work in if it doesn't state. So that's the value of theta here. And I'm going to say that would be our theta. Theta would equal that. It's not letting me type it in. So let me try x. I'm just going to use x. 1. And now it's also saying that secant of x has got to be greater than 0, which is that portions. And if I use the x1, it's not seeming to work. Okay, so secant has to be greater than 0. So you're looking for an answer that falls in here. And this x1 is saying negative 1 point, which would be a good answer. So I don't know if that's going to be the answer. Well, let's just work through this and see if that turns out to be your answer. I'm trying to do the best I can using Desmos. Let's see now going by hand. It says sine theta is negative square root of 3 over 2. Now this one I know I can use the unit circle. How do I know that? Well, because the square root of 3 over 2, that's a unit circle value. So what I'm going to do is first place this on my graph, and then I'm going to zoom in here in a second. Let me see if it's going to be big enough if I do it this way. Zoom in. It's kind of small. I'll uncover it here in a second. This is saying sine theta has to produce a value that's negative square root of 3 over 2. Remember, on the unit circle, all these coordinate points all the way around are in the form of cosine theta, comma sine theta. So negative square root of 3 over 2. You're looking in the y portions. So this is my y-axis. So I'm looking down low. It looks like it's these two squats. The answer is either 4 pi over 3 or 5 pi over 3. One or the other. 4 pi over 3 or 5 pi over 3. Okay, so now that I have that, I'm going to shrink this a little bit so I'm not covering up the next problem. And all right, here, I'm going to circle these up. So theta is either going to be 4 pi over 3 or 5 pi over 3. Now, this says secant has to be greater than 0. As a reminder, secant is h over x. And so if h over x has to be greater than 0, h is always positive. That would mean, by the way, h from here would be 2. We could also state pretty confidently that the only way this, if x is negative, then this whole thing becomes negative. X also has to be greater than 0. I don't know how algebraically to walk through when it's in the denominator, other than to say, if it's true in secant, it's also true in its reciprocal cosine, which would mean a positive, and then you'd just get rid of the 2. And how would you get rid of the 2? Well, in this problem, you can multiply both sides by a half. If I do that, the 1/2 cancels with that 2, and you're left with x. Technically, we're left with 1 over x, but it'll be true of x as well, that x would be greater than 0. Okay, now I just don't know how to do that other than to tell you algebraically. It's true of secant, it's also true of cosine. So even if you took the reciprocal, x is greater than 0. What does that mean for my answer choices? Since x is greater than 0, this side of the graph is eliminated because that's the x-axis here. And that means 5 pi over 3 is my solution. So theta would equal 5 pi over 3. Now I'm going to zoom back out here. Our answer over here is negative. I know how they got that. So 5 pi divided by 3. What they did is they listed as if you went negative, which that would be negative 1 pi over 3. So if I do negative 1 pi divided by 3, I'm going to get what the calculator gave me. Check that out. Same value. Over here, I'm going to put 5 pi over 3 because that's their unit circle value. 5 pi over 3 is what I'm going to say theta is. But it could be anything coterminal. So technically, it could be 5 pi over 3 plus or minus, or I just say plus 2n pi, if you remember when we were doing that, where n is an integer. N is an integer. That just means a whole number that could be positive or negative. So normally whole numbers are only positive. So this would be the full answer right there. I probably should leave it that way. And so what the calculator gave me was this value minus 2 pi. Where n was like 1, that's what the calculator gave me. But I'll leave the answer as the unit circle value there. I know that's hard to see what I did right there, but you know what I could try? Let's see if it'll let me expand all of it. No, it won't. Well, this is where I got the values from. There was one. Whoops. That's not working. There was one of them right there. There was the other one. This is for number 8. So that's where I got those values originally, but we said x had to be positive. And so that eliminates this portion. Since x has to be greater than 0, we eliminate that portion. X is greater than 0, that goes away. And so theta had to equal 5 pi over 3. I don't remember on the test if I put that 2n pi, but it might just be 5 pi over 3. Okay, with that, let's go back and do number 9 now. It says if, let me send this to the back, order, send the back. Okay, if tangent, that's too far. If tangent alpha, that's like an A, is 5/12 and is located in quadrant 1, and secant angle B here, beta, is negative 25/7 and is located in quadrant 3, find cosine of A minus B. That's a formula we learned on lesson 5.4. So this is the first time we've gone to the formula chart that I remember of this class. So what I'm going to do is show you under the sum and difference identities, it wants cosine A minus B, which is located right there. Oops, I had it. I accidentally double clicked. That formula right there. That's what we're trying to solve for. So this says find cosine of A minus B. That will be equal to the cosine of alpha, and I'm just going to use English A, times the cosine of beta, English B, plus sine alpha, sine beta. That's what I'm going to be looking for. Now, what does all this have to do with anything? Well, this is telling me about my values. It's saying that the alpha condition, you have tangent is, let me go over my right triangle trigonometry calculator. Tangent is y over x. That's telling me my y over x is 12/5. We could do Pythagorean Theorem and learn that 5 squared plus 12 squared is going to equal my hypotenuse squared. For the sake of time and space, I'm going to just tell you that if we do this, we're going to get that h is equal to 13, and h is always positive. So how do can I prove that to you? Yes, I can. I'll just show you here. 5 squared plus 12 squared is 169, and the square root of 169 is my 13. So h is 13. So that's the case for alpha. Now for beta, they're giving me secant. Now secant is h over x. And h is always positive. So I just realized I wrote that wrong. I meant to write colon here. H over x, and h is always positive. So I'll put the 25 as being positive, the x as -7. What that means is if I need to find my y value, I would take my -7 and square it, plus y squared, and that will equal my hypotenuse squared, which happens to be 25. This says it's located in quadrant 3. If you think about quadrant 3, in quadrant 3, this is quadrant 3 right here, y will be negative. Y is negative in quadrant 3 because it's down low. That's the y-axis, it's down low. So y is going to be less than 0. So when I solve this, we're going to get y equals some negative number. So I'll do Pythagorean Theorem real quick. We're going to have 25 squared, and we'll need to subtract this -7 squared. I'm putting that in the parentheses to make sure I square the negative, which is 576, and the square root of 576 is 24. So y is going to equal -24. When we get to the square root, we normally would do plus or minus, but this one tells us that y is negative. Over here, quadrant 1, everything's positive. In quadrant 1, x is positive, y is positive. Hypotenuse is always positive. So there's my values. So now how does that help me solve here? Well, let's do a little substitution. Cosine of a means I'm taking x and h from a over here. So x is 5, h is 13. So it'll be 5 over 13 times cosine b. I take my x over my h, which is 25. And I don't want to mess this up. It's multiplying a negative here. So let's put that in parentheses. And then we will add sine of a, that's y over h, so it'd be 12 over 13, times sine of b, which would be -24 over 25. I see I'm going to have a common denominator when I do this math. That's going to be great. So the denominators, let's see here, 13 times 25 is 325. Five times -7 is a -35. 12 times -24 is -288. I'm going to switch that and make it -288. So when I subtract these across, let's see here. We have -35 over 325 minus a 288 over 325. As a fraction, that's -323 over 325. So -323 over 325. That should be our solution. Now let's test to see if we got this right. How could we do that? I don't know. I'm going to take a guess, though, how we might be able to try this. So I'm going to clear this off for a second. No, I didn't want to clear the last one. There, I want to leave that one up. Okay, we're going to say, I'm going to take an inverse here, that A is going to equal the tangent inverse of 12 over 5. So that's what A is going to equal. B is going to equal the inverse of -25 over 7. And the one problem with this is that there's no way of stating that's giving you a value secant in, see, the second quadrant. I think in terms of radians, let me turn this to degrees. Yeah, that's second quadrant. We need that to be third quadrant, which, what's the rule for that? I forget. That would be 106 degrees. I'm thinking of a unit circle here, 106 this way. We need to be in the third quadrant, which would be like -106. I think I just need to make the answer here negative, and that would work. Okay, now we go back to radians. Okay, I had to put a negative there and make it be quadrant 3. So now I have my two angles. We want to check what is cosine of alpha minus beta. It gives us this. My goodness, they match up. You might not be able to duplicate what I did in the calculator there, but if you did follow that, that would have been able to get you your value. I took the inverse to solve for alpha here and beta. Took the inverse because that exchanges or substitutes domain range. I had to make an adjustment here to put that in quadrant 3. I went to rate degrees just so I could figure out without that negative. 106 degrees is second quadrant. We need it in the third quadrant. So since I need it down in the third quadrant, I just subtracted the 106 rather than making it a positive 106 degrees. I made it a negative 106. So I just put a negative right there. Now I have this in the third quadrant. I have A in the first quadrant where it's supposed to be, between 0 and 90. And so I was able to calculate this correctly. Where we got the same answers. Number 10. So while I'm on this, let's see if we can simplify this first in the calculator. I think this one might be easier to simplify in the calculator. And then we'll do a little spot oil to solve this. It says here that we have cosine times tangent. Oh, I forgot. When you got two trig functions that are multiplying, in Desmos, you need to put parentheses around the x over cosecant plus cotangent times, oh, I need to do a fraction here. Cotangent times sine. Make sure I type that in right. So I'm looking at it. And it's giving me a solution across here. It's a constant line, which means it's a number value. So this is a little cheat way if you want to just say x equals like that. No, that didn't work. Let me. I wonder why it's not giving me a number value. Well, that should equal some value, which it looks like it's a constant line at the number 1. So my answer, it appears, is going to be 1. So I just typed that in the graph and saw it's a constant line of 1. This is not set equal to x or anything like that. So let's just see what we get here. Let's try it by hand. I'm going to follow spot oil. Let's see if it's right. Simplify. You can try to do a little algebra here to see if you can simplify. So you're looking for anything that can cancel out, which in this case, nothing does. And I'm going to zoom in just for this problem. Zoom in a little bit more here. So I can't simplify. So then you try Pythagorean. You look for ones and squares. Ones or squares, if not both. I don't see either. So move on. O stands for spot oil, opposite denominator. The technical trick is called conjugates, where you have 1 plus or 1 minus a trigonometric function in the denominator. I don't have any 1 plus or 1 minus, so I move on to T. T stands for transform to sines and cosines, and that's what I'm going to do. On the formula chart, I'm going to go to reciprocal identities, reciprocal identities, and I'm going to look in particular for cosecant in the denominator. So cosecant in the denominator is right here. Cosecant in the denominator, it's not letting me really highlight this the way I want to. That's better. Cosecant in the denominator is equivalent to sine in the numerator. They're reciprocals of one another. So I can actually get rid, I can substitute out the cosecant in the denominator and move it, make it sine in the numerator. So this would become cosine times tangent. I'm going to put little dots so you can see they're multiplying. Times, instead of dividing by cosecant, you multiply by sine. That's what a reciprocal does. Now on the other side, I have a secant in the denominator. So I'm dividing by secant. Well, dividing by secant is right here. Dividing by secant is the equivalent to multiplying by a cosine. So instead of dividing by a secant, I'm going to multiply by a cosine. So that was the T, the transform, and that was called reciprocal identities. Now I'm looking, start back over on spotted whale. Can I simplify by canceling? Still cannot. Pythagorean, nope. No more denominator, so that's out. I can't do that one at all since there's no denominator, so I'll just go ahead and cancel that out. T, can I transform anything else? And the answer is yes. I could transform the tangent and the cotangent. Those are what we call quotients. Tangent, it's not written over here, but I do have it on the calculator, is y over x, which means it's sine divided by cosine. Okay, so I know it doesn't show up in the formula chart, it's unfortunate, but this would give us cosine times, tangent is sine divided by cosine times sine. And I realize I put an x there. Let me correct that. I mean, I put a theta there. I should have put an x, because that's the variable we're working with in this problem. Now, cotangent's the reciprocal, so it would not be sine divided by cosine. It would be cosine divided by sine. So now I start back over. After doing the quotient identity, I ask, can I simplify by algebra? Yes, I can. I'm multiplying by a cosine, I'm dividing by a cosine. I'm dividing by a sine, I'm multiplying by a sine. I can also say, well, sine times sine is sine squared. And cosine times cosine is cosine squared. Well, according to the Pythagorean identity, sine squared plus cosine squared equals 1. And so, yep, the calculator gave us the right answer, 1. All right, lesson number 11. Find all asymptotes for the graph. Now, this was a 3-step problem. And so it was a 3-step problem from lesson 4.5, where you could look back at those steps if you wanted to. But I also created a calculator to try to figure this out. And so I'm going to close this Desmos. Let me open up, it was called Graphing Trig Functions, functions with asymptotes in particular. Okay, and so the way this works is you would first on the top line type in the equation, which I almost have. I just need to add the -4. And what this does is it says, okay, find the first asymptote, which that happens to be in the right location. It looks like it's dividing this graph that's shown in blue, the tangent x minus 4. That red dotted line is dividing those two pieces apart. And then you find the periodic asymptotes, the part that you add to it, which we learned is without a transformation is always n pi away without a transformation. And that's when you drag this around, if it's right, it should divide each individual piece, which it looks like I got the answer automatically right here. I didn't have to do any work. Looks like it's going to be x equals, the a is pi over 2 plus n pi. That's what the answer is going to be. What do you know about that? The calculator in standard form is the right answer, pi over 2 plus n pi. And you would need to say n is an integer, where n is an integer. Now, how do we do it by algebra? There were 3 steps. And so the first step, if you remember, was to determine what are we dividing by? Because an asymptote occurs when you divide by 0. And so tangent, like I just said on this problem, tangent is sine divided by cosine. We had an asymptote when cosine, or x, equals 0. So the first step was set the denominator equal to 0. And so you could say cosine equals 0, or we could just say, for simpler terms, x equals 0. And so now, using a unit circle, you look at the places where x equals 0. This is step 2. Step 2. You find when cosine equals 0, or we could say x equals 0. So this is the x-axis here. And so we're looking at the spot on the y-axis because that's where x is 0. X equals 0 right here in the center of the graph. And so it would happen at pi over 2. Notice up here, x equals 0, and x equals 0 here too. or 3 pi over 2. So the answer to this problem is, and we just took the first. So it was pi over 2 or 3 pi over 2. And we just, on our lesson, took the first one. And step 3 said apply horizontal transformations. That was what we learned on lesson 4.5. This problem has no horizontal transformation. That would occur on the inside with x. There's none. So the answer was you would just take your pi over 2 and then plus n pi. And that n pi technically should start on this step. So we would just take the first one, which is pi over 2, and then you'd add n pi because they're always periodic. And without a transformation, all asymptotes with trigonometry are n pi away from one another. So that's where the n pi came from. There was no transformation, so that was our solution. And the graph would support that decision. All right, number 12. Now what I want to remind you in number 12, let me close this one. I want to get back to just the basic trig. And I'm going to close off this other stuff. So it's just all we're looking at are these 3 lines. It says find the exact value of cosine 15 degrees. Let me check my mode here, degrees. So that would be the correct answer. And sine of let's do parentheses, 5 pi over 12. Now this one would be in radians. So you need to switch mode to radians. So sine of 5 pi over 12 is going to equal 0.9659, so on and so forth. And cosine of 15 in degrees is 0.9659, so forth, which it looks like. Let me go back. I think those answers are the same. Looks like those 2 decimals are the same. Let's check it out. So how would I do this by hand? I'll just leave that in the radian one. It says find cosine at 15 degrees and sine of 5 pi over 12. Well, we usually use like unit circle for this type stuff. It's a great little cheat for us. I say cheat, it's a resource, it's not actually cheating. And so I would be looking on the unit circle, and we notice right off the bat that 15 degrees is not listed. That would be 15 degrees. The cosine would mean the x value. So we're doing this x, we're trying to see how long is this x right there. That's what we're trying to find on this portion. And then we'd have sine of 5 pi over 12. Now you might not know this, but 5 pi over 12 is almost 1/2 pi. It's really, really close. Here's 1/2 pi. This is almost 1/2 pi right there. That's where 5 pi over 12 would be located. This says find the sine, which is the y value. You can see that this is almost up to 1, just like this is almost over to 1. So that's why the answers will be the same. So what's the math though to find this? We learned on lesson 5.4 that if you have a value that doesn't happen to fall on the unit circle, you could use unit circle values to solve for it if you use your sum and difference identities. So for cosine, I would need to use one of these 2 formulas here to solve for 15 degrees, which means I just need to find 2 angles that either add or subtract to be 15 degrees. I'm looking around, there's a lot of them. I could say 45 minus 30 is 15, 60 minus 45 is 15. I could go over here and say 135 minus 120 is 15. You can choose any one of those and you should get the right solution. I'm just going to choose the first 2. I'm going to say, all right, I'm going to work with here 45 and 30 degrees. So I'm going to say that cosine of 15 degrees is going to be equal to cosine of, in parentheses, 45 degrees minus 30 degrees. And that, according to this formula right here, will be equal to cosine of A, which happens to be 45 degrees, times the cosine of B, 30 degrees. Ignore the negative. All the negatives is going to deal with is this symbol here. It's going to become a positive of sine 45 times sine 30. All that will mathematically find the length of this x value at that spot right there at 15 degrees. So cosine of 45, I go to the 45. At 45 degrees, the cosine is square root 2 over 2. At the 30, the cosine is square root 3 over 2. Sine of 45, the y is square root 2 over 2. And the sine at 30 is 1/2. I can simplify these. I notice they'll have a common denominator. They both have 2 times 2, which is 4. Square root of 2 times square root of 3 is square root of 6. And that just becomes 1 times square root of 2 is just square root of 2. Because of the common denominator, I can write that as my answer. So it would be 1 fraction. Oops, I don't know what just happened there. And it would be square root 6 plus square root 2. You cannot combine square roots that are adding and subtracting. So you have to leave that separate. But that would be my solution right there. Take that away. So that would be my solution. Now, we think that sine of 5 pi over 12 would match or create the same answer choice. Let's see. So sine of 15 pi, or excuse me, 5 pi. My board is respawning really slowly all of a sudden. I don't know what's going on. Sine of 5 pi over 12. Well, what two angles add up to be 5 pi over 12? This is a little bit trickier. So what I taught you on lesson 5.4 with terms of radians is if you have a value that's not on the unit circle, like denominator 12s are not even on there, what you do is you're going to add it as two fractions. And when you add two fractions, they must have a common denominator. So both have a denominator 12. Since they're terms of pi, I'm going to put pi in both of these fractions. You're going to find two values that add to be 5. So like, for example, 1 and 4. But can reduce with the denominator, which 1 and 4 would not work because 1 does not reduce or simplify. The reason I need them to simplify is I need to find two angles on the unit circle, and neither or none of these angles have denominators 12. So I have to have values that reduce. So 1 and 4 do not work. Even though they add to be 5, they don't. This 1 does not reduce with 12. However, 2 and 3 would work, because this would become pi over 6. This becomes pi over 4. And those two values are right there. So I'm going to rewrite this as saying sine of 5 pi over 12 is equal to sine of pi over 6 plus pi over 4. Come over here to my formula. I'm now going to use this formula because I'm adding the two angles. And so we'll say sine of pi over 6, so sine of A, pi over 6, times the cosine of B, cosine of pi over 4, plus cosine A times sine of B, pi over 4. Once again, we'll substitute our values. Sine of pi over 6 is 1/2. Cosine of pi over 4 is square root of 2 over 2. Cosine of pi over 6 is square root of 3 over 2. And the sine of pi over 4 is square root of 2 over 2. Once again, we have common denominator. You'll notice I have here denominator 4. And 1 times square root of 2 is just square root of 2. Again, denominator 4. Square root of 3 times square root of 2 is square root of 6. We have the same solution, just the numerator written in opposite order, but those would be equivalent to one another. So that's number 12. Oh, the one thing we never did is that going to give us the same answer. This is the value we're looking for there. It was in radians. This one's in radians. This one, I'll change it back to degrees in a second. Let's type this in. We think the answer is going to be square root of 6. Forgot to create the fraction first. Square root of 6 plus square root 2 divided by 4. Notice these decimals match. And then when I change to degree mode here, notice now these decimals match. So yep, we did do it correctly. So you could have done all that with the calculator if you just remember to change your mode accordingly. Let's take a look at number 13 now. 13 says to simplify all this. This is a spot oil problem. Well, I would recommend check with your calculator first. Sine x, it looks like it's multiplying. Any trigonometric functions that are multiplying, you need to put a parentheses around the angle portion, which would be the x in this problem. So I'm typing this in with parentheses. Extend this out a little bit larger so you can see. It appears to me it's a flat line answer. That means it's going to reduce to be a number. And the number, since it's flat line at 0, let me zoom in here. You see the answer is at 0 here. So the answer should be 0. When I simplify all this, I should get 0 or nothing. Let's see. So I do spot oil here. I have sine x times tangent x, cannot simplify, minus secant plus cosine, can't simplify anything. So I try Pythagorean. You look for ones and squares. Don't see anything. Opposite denominator, that's conjugate. I don't even have a denominator, so that's going to be an impossible step here. T, transform. Can I transform anything to sines and cosines? Yes. I can transform tangent. Tangent is sine divided by cosine. Sine is y, cosine is x, tangent is y over x, so it's sine over cosine. And I can also transform, that right there is called quotient identity. I can also transform secant. Secant is the reciprocal of cosine. So secant could be written as 1 divided by sine. 1 divided by, I said sine, I'm sorry, cosine. Apologies. And now I pick back up. Plus this cosine. So I have two fractions, and these fractions happen to have a common denominator. So I will be able to combine those. I'm going back through spot oil. This is doing algebra. You can see it can simplify sine times sine is sine squared. I have a common denominator here, so I can write that as one fraction. So it'd be sine squared minus 1 plus a cosine here. Now I go back through, I've done some algebra. So I come back and it says, let's see, can I cancel anything, do more algebra? The answer is no. I would like to say I can cancel those, but those are terms, it's adding. You can't, if they were multiplying, then I could cancel those, but they're not. Pythagorean, do I have ones in the square? Yes, I have a squared and a 1. So I'm going to go to Pythagorean Identities and look for the Pythagorean that has a sine squared, which happens to be the first formula. But we need to manipulate this formula. The formula is written as sine squared plus cosine squared equals 1. Over here I have sine squared minus 1. So if I subtracted 1 from both sides, I do now have sine squared minus 1, but I right now have a positive cosine squared. And so what I would have to do now is to make it just sine squared minus 1 is I need to subtract this cosine squared from both sides. And so sine squared x minus 1 would equal negative cosine squared. And so that's what I'll substitute in right here. And that sine squared minus 1 will equal negative cosine squared. So I'm going to do a little visual here, a little visual aid. Okay, so we're going to say negative cosine squared x over cosine. That was Pythagorean right there, plus a cosine. I start back over on spot oil. I try to simplify with algebra, and I can this time. I have cosine squares being divided by cosine. This one dividing cosine can take out one of those two squares up in the numerator. So now I have negative cosine x plus cosine x, and that equals 0. A negative cos plus positive cos cancel each other out. Simplify, leaving it with nothing. So the answer is 0. All right, that was the last few there. We saw quite a bit of chapter 5 stuff. So that kind of puts an end. There's one more I see down here. We'll get to that one in a second. But that puts an end to most of those conversions like that. Let's go on to number 14 here. It says the right side view of a skateboard ramp is a triangle. And you're going to learn with trigonometry, you're going to like real worlds a whole lot more because typically we deal with positives and you're not doing a simplification of using identities. So side view of a skateboard ramp is a triangle, ABC. So we have a triangle here. Angle A is 59 degrees, B is 91, and C is 25 feet. Okay, so I have a triangle and it's not a right triangle. They say we have to have a 91-degree angle. So let me think. If this is, if that is 90, this needs to be slightly more. So 90, 91. So there's going to be my triangle. I'll do it like that. So this is my angle B, 91 degrees. 51 or 59 is a second angle, which it looks like. Oh, I should have made this one larger than the other. Let's do it this way. So now I can see that this angle is really small. This one's a larger one. I want to make this one be 59 degrees. Which is angle A. Now angle C, we don't know, but we do know side length C is 25 feet. So I'm working with this triangle. The first thing I'm going to do is find this angle. In a triangle, how many degrees are there?
180.
180, yeah. So I'll take my 180 and I'll subtract these two angles, 91 and 59. Let's go to our calculator. 180 minus 91 minus 59 leaves us with 30 degrees. So now I have all three angles and I have a side length. I have what I called on lesson 4.7 a completed set. I can use the law of sines because I have, or I sometimes call it a pair. I have the angle and the side across from it. So law of sines says you can take any pair, you take the sine of the angle over the side length, and you can set it equal to any other pair in the triangle. And so we're trying to find B here. Lowercase b is across from capital B, so it'd be right there. That's what I'm trying to find. So I'll set it equal to this pair here. So it'd be sine of 91 degrees over lowercase b. We could cross multiply and divide, but I'm just going to use my calculator. Desmos graphs, law of sines, and we'll type in our values. Angle A is going to be 30, or not this A, but according to my ratio here set up. So sine of 30 over 25 is going to equal sine of 91 divided by unknown B. I'll hit X. You can look at where they cross here on the graph, or you could just look at this. We were rounding to the nearest thousandth earlier. This doesn't say, so I'll go nearest thousandth. B is approximately 49.992. I'm running out of space. Let me see if I can slide over. Yeah, I can. 0.992. And we're in feet. And so that would be my solution. Again, if you wanted to do this by hand, you would you'd do cross multiply. So you'd have like 25 sine 91 equals B times sine 30. And then you would divide the sine 30 to get your answer. So what would end up happening, this is the algebra, if you don't want to use this calculator, is you'd have 25 sine of 91 degrees divided by sine of 30. That's why I call it cross multiply and divide. Your many DIST teachers call this butterfly technique. I was taught cross multiply and divide. I like that because it tells you what to do. You cross multiply without the variable, then you divide by the one with the variable. And that would give us B there. Notice the same answer. So that's number 14. Let's try 15. In geometry, Miss Lindsay designated a triangle area in the auditorium for art projects. The dimensions of the triangle are 48 feet, 31 feet, 45 feet. What is the area of the triangle? Okay, so this time I have a triangle with no angles. All I know is I have one length that's 48, another length that's 45, so almost as long. Let's go like that. And one that's 31. So my longest side is 48 feet. My shortest side is 31 feet. My middle side is 45 feet. We want to find the area. Well, I also in lesson 4.7 gave you a formula for this. It's called Heron's formula. And it said that the area is equal to half of the perimeter times half of the perimeter minus one side length times half the perimeter minus another side length times half the perimeter times the final side length. You just take the square root of all that. And where, let me write this in, where S would equal half the perimeter. So 48 plus 31 plus 45 all divided by 2. If you typed all that in the calculator, you should get your answer. Well, I also created a calculator for this. So I'm going to go over here and cancel these. So I don't have as many tabs open. Let's look for area of a triangle. There it is, Heron's formula. When I click this, this will do the calculation for me. Notice that's my formula right up there. And there's my S. So we have 48 as the first side length, 31 is the second side length, and the third side length was 45. I type all that in. Here's my solution. The half the perimeter is 62 feet. The area here, or the area of the triangle, to the nearest thousandth, I'm going to continue rounding the same value, would be 676.340 feet squared, since it's area. All right, number 16. Point P is rotated 120 degrees clockwise around a circle. Now, anytime you see circle, you should think unit circle. With a diameter at 20 meters. If the center of the circle is at the origin, what coordinate represents P prime relative to the center? So here's a center 0, 0. P has been rotated 120 degrees. I'm going to give you a slide here. What number are we on? 16, I think. Yeah, 16. For number 16 here, I'm going to get the point at 120 degrees. It said P is rotated 120 degrees. Here's my point. Excuse me, there's 120 degrees. That's the coordinate point right there. But for a unit circle, which this is, a radius equals 1. So on this problem, this radius here is equal to 1, or said this way, that radius across here is equal to 1. On our problem, so I'm going to take this point. On our problem, it says the diameter is 20 meters. If diameter equals 20 meters, radius is half of that. So the radius equals 10 meters. So what I'm going to do is I'm going to have to multiply that point by 10. So we'll come back over here. And so basically what we'll have to do is if I want to make this 10 meters, then I need to multiply this by 10 meters. And so that'll be the math that happens. I'm going to take away the meters for a second and multiply that by 10. And so we'll distribute that through. And it looks like we're going to get -5, 5 squared roots of 3, because both of them, when you multiply by 10, you divide by 2. Oops. And so that was the math here. So it'd be 5 times -1/2 square root of 3 over 2, which equals -5 meters to the left and 5 square roots of 3 meters up. That would be our solution right there. And that's just because you had to scale it for a radius being 10. All right. Number 17. I really need to go back and reevaluate these values. These are not very good. But what we learned in lesson 5.3 is that we can use your calculator to solve all these problems. So I'm just going to get a blank calculator here, and I'll show you. So nothing special here. On Desmos, what you do if you want to end solve or solve problems is you type in the problem as given. So 3 tangent squared x plus 2 square root 3 tangent x minus 3 equals 0. And you can see there's a multitude of answers. That's what this all values of x is. It's showing you all the coterminal answers. We're going to want the ones that are, we're going to have to find all of them, but I'm going to first find the ones that are within 2 pi. And then we'll replace the others. So what I'm going to do now is I'm going to first copy the left side of the equation and have that as its own equation, and then copy the right side, which was just a 0. So I graph the whole thing, then I graph y equals the left, then y equals the right. The intersections are the solutions. So the first ones you would list, you go from the positive. When I list them, I listed the first ones that occur on the positive side of the graph. So the first intersection is a pi over 6, and then 2 pi over 3. And 7 pi over 6 is periodic. That's 1 pi away. That's periodic because it's a pi over 6. I'm going to prove it to you. This next one's going to be a pi over 3 because they're repeating each other. So notice how these are adding 1 pi. And so from here on out, all the rest would be periodic. So pi over 6, 2 pi over 3. Another pi over 6, pi over 3. Whoops, let me zoom out just. Okay, pi over 6, 2 pi over 3. 7 pi over 6, 5 pi over 3, pi over 6. See how they're repeating? There's repeating over and over and over. So we know the answers are going to be pi over 6 and 2 pi over 3, where they repeat every 1 pi. That's what that just said from the calculator. So pi over 6 plus n pi and 2 pi over 3 plus n pi. Again, where n is an integer. That's going to be the solution to number 17 using calculator. I graph the whole thing. I graph y equals the left, y equals the right. If you're going to use algebra, what's harder on this problem is this is written as a quadratic. On the formula chart, they have this on the second page. It's written as a quadratic. Ax squared plus bx plus c. It's in that form. It's kind of like solving the algebra of 3x squared plus 2 square root 3x minus 3 equals 0, which normally we would try x method. But we have a problem on this one. And that the problem is when you multiply, here you get -9, but you're looking for factors of -9 that add up to be 2 squareds of 3. And that's where it's a little tricky. So factors of -9, one's positive, one negative. And what I'm going to guess is, just because I've been doing a lot of math, this might be totally new to you. I'm going to guess it's 3 squareds of 3 and a -1 square root of 3. And I put the 1 there just so you can see the math. So 3 squared 3 minus 1 squared 3 is 2 squares of 3. And I think if we multiply, that would equal -9. I think. Let's test that. That would just be a guess, but I'm not expecting you to be able to guess that. And when I multiply this times -1 square root of 3. Yeah, that is -9. So those are the two numbers. I wouldn't expect you to be able to guess that. So what would you have to do if you can't do quadratic x method? That's because they're not rational. These are not rational. What do you have to do? You use quadratic formula. And so we would use this formula. What's different though is this is tangent x, not just x. And so I'm going to say, instead of just x, I'm going to say that tangent of x is going to equal the -b plus or minus b squared. Let me put a parentheses there. Minus 4 times my a times my c. And you realize real quickly that calculator is the way to go on this one. All over 2 times a. So this problem I can take all day, or I can go a little bit quicker and just tell you as I go. That's -2 squares of 3 plus or minus. Okay, when you square this, it's a square root, or 2 times 2 is 4. Square root of 3 times square root of 3 is 3. So That's going to be 12. If you don't believe me, I'm just going to show you right here. 2 square root of 3 squared should equal 12. And it is. Minus 4 times 3 times negative 3, which means it's going to be plus 4 times 3 is 12 times another 3 is 36. All over 6. To simplify, I'm going to write this as 2 different fractions. It'll make it easier for me. I'm going to have negative 2 square root of 3 over 6, so I can simplify this. And I'll have plus or minus. This is the square root of 48 over 6. Now here's another square root to reduce. So 48, I'm going to take 2, go into 48 24 times. 2 can go into 24 12 times. 2 can go into 12 6 times. 2 can go into 6 3 times. When I circle up my pairs, that means I'm going to have 2 times the square root of 3. Single goes underneath. These pairs multiply. And so I have negative square root of 3 over 3 plus or minus. That's 4 square root of 3 over 6. And now I can reduce one more time. 2 goes into both of these. This will be 2. This will be a 3. So I see I have a common denominator again. So I'm back to a common denominator. Negative square root of 3 plus or minus 2 square roots of 3. All that is equal to tangent x. And so how does this compare to my answer? When I see, that means there's 2 possible answers here. When I reduce that, I could have a negative square root of 3 plus 2 square roots of 3, which would be 1 square root of 3 over 3. And, or I could have negative square root of 3 minus 2 more square roots of 3, which is negative 3 square root of 3 over 3. Which simply becomes a negative square root of 3, which is exactly what I was going to be getting over here when we reduce. So that's what tangent x is, and you would find the inverse, which if that wasn't enough work for you, you do this last step and you'd say x is equal to the tangent inverse of square root of 3 over 3, or tangent inverse of negative square root 3. And by the way, the reason the symbols are opposite here is because we'd have to put this in parentheses, and if you remember inside lies, the negative, they would switch signs because of the lie. So that's why these are opposite sign. That's a negative square root of 3 there. This one, when it reduces, it will be divided by, it'll get divided out. So that's why they're looking different. I said that backwards. This one will become the positive and get divided by 3 because you'll have to reduce out the 3. This one gets divided by 3, but it becomes a negative. So the 3's will get divided out. So that would be my solution. I'd be looking for those on the unit circle, which I can just tell you now for sake of time. This is when, if you unrationalize the denominator, y is 1, x is square root 3. Do I have a unit circle up right here? I don't. Y is 1, x is square root 3. So y is 1, x is square root 3. Happens at pi over 6. And it repeats. And then when tangent is negative, that's when y is negative square root of 3, x is 1, or vice versa, with the negative, which is right here, 2 pi over 3. Wow, that was a hard problem. That's no good. I would use calculator, and don't worry, on the test I simplified the problem, so you won't see it like that. That was kind of ridiculous. I don't know why I had that to begin with. But that's how you would get these answers. like that. I shouldn't say or, let me put a comma in there. That's a better way of writing it for math. So there would be your solutions. All right, I got 5 minutes left. Let's finish off these problems. We've got 3 more to look at here. And number 18, it says 2 tracking stations are on the equator 205 miles apart. So here you are. Equator means like horizontal. A weather balloon is located on the bearing of north of 41 degrees east of the eastern station. So north means you start north and you move 41 towards the east. That's why the angle's there as a 41. And the western station is north. So this is pointing north, 71 towards the east to get the balloon from the western station. How far is the balloon from this western station? That's what we're looking for. Round to the nearest 10th. Well, to solve a triangle, you can solve any triangle with law of sines or law of cosines. Any one of them can be solved in that way. So what we're going to do is we're going to try to solve this triangle using either law of sines or law of cosines. So to do so, I need to solve for values inside that triangle. So the first thing I can do is I recognize that's a 90 degree. So I can say this is 90 minus 71, which is equal to 19 degrees. So I got that angle. And I can say this angle right here, that's a 90 plus 41. So it's 90 plus 41. So that's 131. And if you know 2 angles, you can get the third by subtracting from 180. So let's type this calculator to see what we get. (180) minus 131 minus 19 is 30 degrees. Once you recognize you have a completed set, we have a side length and an angle across from it, you can use law of sines. We can say that sine of my completed set or my pair, sine of 30 over 205, will equal any other pair or set in the triangle. So in this case, we're looking for that question mark. So we'll say it's sine of 131 degrees over x. And this is the law of sines. So I'm just going to use my calculator to get my answer here. Let's go Desmos, law of sines, calculator number 15. So sine of 30 over 205 equals sine of 131 over x. The answer, you don't see it here, it's because it's so large, you have to zoom out, but it says it's 309.4, it says round to the nearest 10th. So I'm going to say 309.4 miles. Okay, now let's check out number 19. So again, I know the word problems can look like a lot, but they're actually a lot easier because they're only positives, and it's usually I have a calculator for them. Okay, so here's number 19. In a baseball game, a ball is hit on a north 38-degree angle, so here, to the right field wall, about 372 feet away. The player in the right field must make a throw all the way to third base, which is here. How far of a throw, that's this distance, must the player make to reach third base, round to the nearest foot? So let's look at this as a triangle here. We have this triangle that we're dealing with. From home to right field wall to third base, and third base home. What we are given is that is 90 feet. We're also given this distance to the right field wall is 372. I'll write that right there. We're told this is 38 degrees. Now, I want you to see behind my triangle, you have a box. And in a box, all angles are 90 degrees. So this from here to here is 90. That north is halfway across. So this side would be 45. This is 38. That angle right there is going to be 45 plus 38 degrees. 45 plus 38 is 83. So I have an 83-degree angle. Now I can look, do I have a completed set? And on this problem, that shouldn't be a degree. I don't. I have these 2 side lengths, but I don't have an angle across from them. That's less than 90. So I would have to use the law of cosines. And so the law of cosines I'm going to open up this calculator, Law of Cosines, and I'm not going to write out all the values because see the clock here. We don't have, this is the side length we're looking for, so we're looking for the side length, but we do have the angle across from it, which is 83 degrees. My sides are 90 and 372. This problem says round to the nearest foot, so I round that value to the nearest foot, which would be 372 feet. That would be my answer here. All right, and last one. It says the terminal side, the ending side of an angle in standard position coincides with the line y equals 3/4 x in quadrant 1. Okay, so let me just, we have x and y axis, the terminal side of an angle, coincides with the line y equals 3/4 x. Now, if you remember y equals 3/4, that's a rise over run. That's saying it goes up 3 every 4. So it's going to be something that looks, let's say that's our line here, where it goes up 3, 1, 2, 3. For every 4 it goes over. 1, 2, 3, 4. That's a slope of 3/4. So the rise equals 3. The run equals 4. Or said another way, the y equals 3, the x equals 4. This says find cosine in quadrant 1. So if you look at this as a triangle, the cosine would be the x divided by h. What do we know? The run, it says, is 4. That's our x. We need to find our h. If the y is 3, this is a 3, 4, 5 triangle. That means h is 5 by Pythagorean Theorem. So cosine would be 4/5. And that would be my solution there.